Hi, I'm Peter. This is my Pinewood Derby, or not my team's Pinewood Derby car. So the challenge for the project was to make a car that goes down a hill faster than other people's cars that are going down the hill. There were very specific rules about like the length of the car and the width of the car and the weight of the car, the size of wheels, and that you were only allowed to use the energy from the stored potential energy from the car being at the top of the hill. So there was no spring energy that could have been stored in there or batteries or anything like that. You could only use, it's called potential energy. The gist of how the car rolls is called conservation of energy. So at the top of the hill, you have potential energy, which is based on the difference in height from where you start and where you end. So you have a potential energy relative to the bottom of the hill. And then when the car goes down to the bottom of the hill, all of that potential energy gets converted into kinetic energy. And there's a pretty straightforward equation for that. So the bigger you make h, the faster your velocity will be at the bottom. And that's actually something that I pitched to our team, was that all we needed to do was optimize h, increase h as much as possible. One restriction that was not in the rules was the height of the car. That was left out, and I noticed that immediately and figured we could use that extra height to make our mass higher initially, and then when it gets to the bottom of the hill, the mass would drop, and so we would have effectively more net potential energy to start with than everybody else. But ultimately, I think the group was pretty skeptical that it would work, and so I was tasked with simulating it before we started any design, and I have like a pretty straightforward 2D dynamics analyzing software where you can simulate that sort of thing. Showed it to the team, and it showed us that the car was going to go faster than if it didn't have this, so kind of proved that it should work. So I think we did that simulation, we had the good idea, and then we waited until it was like a week before the competition to start actually designing it. So what a gear train enables you to do is for a given motion, so like this thing rotates like a pretty small, like what's that, like 20 degrees, but we want the rear wheels rotating a lot. So the gear train essentially converts that small 20-degree motion into many, many revolutions of the rear wheel, pushing the car to go further, which worked out really well. I actually stayed up till like 2 a.m. working on this gear train on a work night. But anyway, yeah, I printed it in the morning, put it together, then we tested it on the desk, and it worked really well. It was super satisfying. Ended up working well on the ramp as well, which is important. The project was super fun. It was great working with the team and coming up with a solution that was more about creative engineering solution and less about making the car perfect. I think we did a good job, and I'm stoked for next year. I hope that more people bring their game and design some cool, crazy mechanisms.